Welcome back to our training series on Cumulocity Edge. In this part, we're going to have a look at the Kubernetes-native approach for setting up your Edge instance. This way of installing Edge is a bit more manual, but it gives you more control over every step. You want to consider this if you already have a Kubernetes cluster running on your target host, in which you want to deploy all the Edge components, or generally speaking, if you want to customize the basic setup to your environments and needs. For this, you will need access to your target host machine or virtual machine. For the demonstration, I'll be using a Ubuntu Hyper-V image, but any compatible Kubernetes should be viable. Note, however, that Cumulocity Edge has been only tested with single node clusters and Kubernetes versions 1.32 and upwards. Also, the basic hardware requirements for Edge will still apply. That means 100 gigabytes of disk space, 16 gigabytes of RAM, and at least 10 cores. In case you install additional components, your virtual machine or target host should be even bigger. This training assumes that your Kubernetes cluster is up and running. You can check this with your default tools like kubectl. For demonstration purpose, I'm using K9s. I set up a microcade single node cluster on this virtual machine, and as you can see, it's pretty much empty apart from the standard components. Cumulocity Edge uses a custom operator to install and manage the actual Edge instances on your cluster. The first step is therefore to download and install the operator from the remote registry via Helm. You can grab the example command from the documentation and just fill in the credentials if you want to use the default Cumulocity registry. Note that I am prepending microcades here because I'm using the built-in Helm implementation of microcades. The command should just work as fine with the default Helm. In case you want to host and use your own registry, you have to make sure the connection to the registry is configured correctly. The documentation has also step-by-step instructions for updating core DNS, setting up the SSL connection, and syncing all the required artifacts to your registry. In case you would want to use your private registry, you have to add the URL and port with -r as additional arguments to this command here. For demonstration purpose, I will just stick with the default one. You should have received the credentials from Cumulocity support. In case you're using your own registry, you would get them from your own operations team. The command will take a bit to execute, but you should be able to check the progress with the logs of the operator. You can also check that the operator is correctly running by checking the running ports in your cluster. In this case, if I'm checking now K9s, I should see that now the Cumulocity Edge operator controller is running in a C8Y Edge namespace. We're now ready to actually deploy an Edge instance by feeding a configuration to the operator. The Edge deployment follows the default Kubernetes approach in which you describe the state of your system and the components you want in a declarative way. You describe all these resources within some YAML file and let the operators in the cluster figure out how to instantiate, update, and delete all of this. The actual Edge instance is described as a custom resource definition within a YAML file as well. You can find an example and a description of all the possible values of the CRD in the official documentation. You can merge the different resources into one file like here, or apply them one by one. Just make sure that all the required resources at the Edge instance references are available in a cluster before you apply the config. Typically, this might be something like secrets for the certificates and the certificate keys, but might be also persistent volumes and persistent volumes claims in case you're customizing those or using something else than the default storage class. The exact definition of the resources and which resources you need will depend on the Kubernetes cluster and the context you're working with. For the Edge resources, most of the configuration here is actually optional and have same defaults. Also, you can change most of the things via kubectl commands or even in the UI later on. The important part here is the custom resource definition for the Edge, which essentially boils down to a few mandatory fields, which are the namespace, the version, domain, license key, company, and email. Let's have a look at a more minimalistic example on how this may look like. In this case, we are just using the default domain myownIoT.com, as well as the license key for it. You want to replace those with your own domain and your own license key that you got from the support. We're also setting the email for the admin. Keep that in mind because you will need it for later on for login. We keep the namespace to the default C8Y Edge as we have used that also during the operator install. We can now go ahead and apply this configuration with Kubernetes standard tools like kubectl to our cluster. The cluster operator will now start to instantiate our Edge instance. You can track the progress via the event log of the operator or by just watching the pod status. You can check also the progress in K9s. And have a look at our pods to see that now most of the containers already have been instantiated and are running. Depending on your machine and what microservices you're setting up, the whole booting process may take a while. Once all the containers are up and running, your Edge instance is ready for access. This completes the basic setup of Edge on a Kubernetes cluster in a Kubernetes-native approach. We check on how to configure and access the Edge instance now in the next video.